Okay, so let's try another example for dependent versus independent. So in this case, let T be the number of hours it takes a painting crew to paint a house, and N be the number of people in the crew. A. Define the dependent and independent variable. B. Sketch a graph of the situation. Once again, I recommend reading at least 2 to 3 times. Let's try one more. Let T be the number of hours it takes a painting crew to paint a house, and N be the number of hours, number of people in the crew. Okay, so let's start with A. Independent, well, keep in mind, reference the parents, and dependent, reference the kids. What do you think comes first? Okay, so does T comes first or does N comes first? So T is the time and N is the number of people. For reference, I would say roughly 90% of the problems you encounter, you are going to have time as your independent variable. In other words, your X representative. And N is going to be the number of people in this case. Well, be careful with this, even though I just stated it. So, even though 90% of the cases, time is your independent variable, there are some cases where it might be the other way around. Well, it just happens that this could be one of those cases where the number of people is the independent and the dependent is time. Well, that's kind of hard to tell, right? Especially without having a visual. So let's start B then. And we'll come back to this and see if it's true or not. So B, sketch a graph of the situation. Well, let's see. Let's build a quick sketch. Let's see. X and Y axis. Let's some labels, random labels for now. If we said T is the hours, okay, time, and N is the number of people. Keep in mind this is kind of backwards of what we stated up above for A. T is the number of hours, is the independent, and N is the number of people, is the dependent. Well, let's try some numbers just for reference. Even though we're doing just basic and rough sketches for this particular one, this should give us an idea of what we're looking at. So let's say one person is painting a house. If one person paints a house, they're going to take a long time, right? So there's my rough representation of a long time. Notice I didn't put exact values for how long it takes. Just a rough approximation or rough idea. On the other hand, if two people paint a house, it's definitely going to take shorter time. Hey, what's going on? My graph is going from right to left, rather than the typical book format, left to right. Let's continue one more. If three people paint a house, it takes a short amount of time, right? Hey, it's still going from right to left. This seems kind of odd. And if four people paint a house, etc., we can keep adding more people, and it's going to take shorter and shorter times until basically it takes little time, but there isn't a point where it's going to take zero time, right? There's still going to take some time. Eventually be overcrowded. Well, let's try another graph, real quick graph. That way we can see the difference. Okay, so in this one, if we say N is the number of people is the independent variable, sort of like what we have up at the top for A, and T, the hours, is our dependent variable, or the parents. So once again, some rough values to get an idea of what we're looking at. Okay, so if we say one person paints a house, what's going to take a long time? There's rough approximation of a long time. Two people painting a house, shorter time. Three people painting a house, shorter time, etc. You kind of get the drift, right, or the idea for this. Well, let's take a look. B seemed kind of odd because it was graphing in reverse, and that is correct. It's an odd value or an odd form of graphing, so technically it's not correct, even though I said 99% of the time. T is basically the independent variable. In this case, it's not. So there are those rare cases like this one. So be careful. In this case, our correct graph at the right shows that our number of people, you have to know the number of people, is the independent variable or the parents, and the time it takes is the dependent variable. So you got to know the number of people before you have a rough idea how long it's going to take, right?